Sign, you ready?
Eraser.
Yep.
Alright, the homework. Here's the answers. I definitely wanted to go over the last two, unless you think you just totally got it, but you can let me know what you want to go over before that. So number 1 is C.
Slip down in circles.
Okay, number 1 is C. 2 is E. 3 is A.
Hold on, I'm writing it down right here. So when I sit down, I have it.
4 is B. Don't really worry about the bounded part, it's not really that big of a deal, but 5 is E. 6 is A. 7 is B. And 8 is C.
Why is 7 B?
We'll get to that one. Alright, before the last two, are there some that you want to go over?
Number 6,
What was
please.
8? 6, sure.
Yeah,
8 is C.
I mean, answers.
Alright, number
These solvable
6.
circles.
Number 6. Suppose that's a series with corresponding partial sums. The graph below plots the values of blah, 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 blah. Which of the following statements is false? Okay. What you're looking at is the graph of the partial sums. So, the limit as x goes to infinity or n or whatever of the partial sums is what? If I'm looking at this graph, what is, as x goes to infinity, what is it getting to? Well, I can't really actually, I think they're wanting it to get to 2.5. They want C to be true. They're trying to give you like a horizontal asymptote idea here. So the limit as x approaches infinity of the partial sums is 2.5. They're wanting you to see that that's true. Well, remember what that means. If the partial sums have a limit that goes to a number, that means the series converges to that number. So D is true. The series is convergent, okay? Because if a series is convergent, its partial sums limit goes to a number. But remember what's also true is that if the partial sums go to a number and the series is convergent, that means that the limit of the series is 0. So B is true, but A is not. Because A is saying the limit of the series goes to 2.5, and that's not what it's saying. The limit of the series is, going to go to 0, which means that the series converges to this number, to the number that the partial sums goes to, but the limit of the series is not going to be the same as that partial sums. The rule was if the limit of the series goes to anything other than 0, it diverges. If the limit of the series goes to 0, it converges. So that's why B and C and D are all true. And then E is just stupid. A, so that is so positive.
It's hard.
Yeah.
That's good so far.
Do you get that answer?
I hope so. I'm trying to go hard.
Alright, 7. Okay, for what values is the sequence R sub n convergent? Alright, without this list, I wouldn't know, but obviously they're being really nitpicky. They want to know for what values of R does this thing converge, and we have choices between 1 and -1. Does it include 1? Does it include -1? Or is it bigger than or less than, whatever? So I just went through all of the possibilities, and I said, well, let's, Corey, you're distracting me. Just wait till it's done. It looks good. Don't erase it all. I had to see like what happens when R is greater than 0. What happens if R equals, I'm sorry, greater than 1. What happens if R equals, what am I doing? I'm going to go in this order. What happens if R equals 1? What happens if R is between 1 and 0? What happens if R is between -1 and 0? I looked at like all of the possibilities for R and made my choice from there. Does this make any sense so far?
One of it equals
Did I have to do equals -1? think I was able to maybe rule out that possibility. Let's start in the beginning, then we'll go from there. So if r is greater than 1, okay, if r is greater than 1, so like, let's say r is 2, like 2 to the n. Well then, this is going to equal 2, this is a sequence, right? 4, 8, 16, 32. What's happening as x goes to infinity for that? What's happening to the sequence? It's getting huge, right? It's blowing up. The series is getting bigger, bigger, bigger. So we're diverging here. So if they want to know for what values of r does this converge, well, r can't be bigger than 1. So I was able to rule out choice A. Does that make sense? Okay, so I went to see what happens when r is bigger than 1. When r is bigger than 1, the sequence gets big way too fast. It's diverging, so r can't be bigger than 1. So then I was like, all right, what happens if r is 1? So then I'm going to have 1 to the 1. Well, that's going to equal a series. A sequence is just 1, 1, 1, 1, 1, right? 1 squared, 1 to the third, 1 to the fourth, 1 to the fifth, 1 to the sixth. Okay. So what's the limit? What's the limit as n goes to infinity of this series? 1, right? I'm just always going to 1, 1, 1, 1, 1. 1 to the infinity is just 1. So if the limit of a sequence equals a number, does it converge or diverge? No, it converges. If the limit of a series equals a number, it diverges. If a limit of a sequence equals a number, it converges. Okay, so the difference between a sequence and a series is, if the limit of a sequence, just the list of numbers, if that limit equals a number, then the sequence converges. If the limit of a series, adding up all the stuff, equals a number, that's bad. Then it diverges. So therefore, we're good. R is allowed to equal 1. So now I know choice B and C are the only two that are correct, possibly. Okay, so I could cross out choice D. So actually now, the only one I really have to go check is if R does equal -1 or not. I don't even have to look at these. Okay, I just want to see now what happens at -1 because I've narrowed it down to B and C. So if R equals -1, then I have -1 to the n. Well, what does that series look like? If n is, where do I start? Doesn't matter. If n is 1, I've got -1. If n is 2, I've got 1. If n is 3, I've got -1. If n is 4, I've got 1. Well, what's the limit of this?
Does not exist.
Yeah, -1 to the n. This limit doesn't exist. This is what we call an oscillating limit, an oscillating sequence. Because I'm going positive, negative, positive, negative, positive, negative, but I'm not like honing in on 0. I can have an oscillating sequence that does have a limit. Like if I went -0.8 and then I went 0.6 and I went -0.4 and then I went 0.2. What is this going to?
0.
0. Okay, it oscillates negative, positive, but I'm still honing in on 0. But this one is keeping that same distance away from 0 on either side. It's never getting closer to 0, so my limit doesn't exist. So R cannot equal -1, so therefore choice B is my only choice.
I have a question.
Yeah.
With when r equals 1,
Okay.
I guess I just don't get, because we have this thing where it's like the partial sums, and partial sums are approaching infinity.
That's only
Divergence.
This is only a sequence, though. It's not a series. So the partial sums you're only going to use with a series, because the series is when you're adding stuff up. So you can look at the partial sums means like just a few of those additions. This is just going to be like the first example, which is just a list of numbers. So I'm not adding them up. If this was a series, yes, this would be divergent. But because it's only a sequence of numbers, it's considered to be convergent, and it converges to 1 because they're all 1s. Sequences we actually don't do all that much, but. Okay. Right, this isn't an easy topic. Today's stuff is actually very easy, you'll like it.
Nope.
Question 8. Did you get C? I looked at the limits of all of them, and the limits of all of them were 0 except for C. Basically because for all of them, the bottom grew faster than the top, except for choice C. The powers on the bottom were bigger than the top for like B. For choice A, like e to the n is going to grow a lot faster than n to the third. So that limit is 0. All those limits were 0 except for choice C. So choice C was the only one that went to something that wasn't 0. I'm sorry. It's funny, they actually say what sequence below is divergent. They mean series. So choice C is the only series whose limit is 1, and it doesn't, so that's not going to converge. It's going to diverge. Do you feel totally lost or kind of halfway?
Kinda.
Number 8 should say which series?
Number 8 should say which series. Those are all series. They're not sequences. Okay. Don't stress a whole lot about it. I mean, if you got 1 through 6, if you got 1 through 5, that's good. If you understood 6 when I just talked about it, that's good. And number 8 kind of makes sense. 7's a little out there. All right, let's talk geometric series. Today's going to be an easy day. It'll probably be the last one.
You try and draw circles.
I'm not going to try to draw circles. I can't draw one. This one teacher said how she always used to make her students draw circles on the first day, and the people who draw really good ones, she knew to like be careful about them.
Be careful of that.
Yeah, because if you can draw a perfect circle, you're supposed to be like crazy.
Oh. But Corey couldn't draw a circle. I mean,
He's the what is it called? The exception that proves the
I
rule.
can't draw a triangle.
I mean, that is a triangle. Anything's a
I
triangle.
mean, like, I
Besides.
can't draw a perfect triangle.
That makes sense. I'm like, wait a minute, you go up first.
Cuckoo.
Yeah.
You're cuckoo.
I love cuckoo. I love cuckoo old people.
That's me, you when you get older.
don't like purposely screw up.
No. It's actually not that bad. I taught geometry for like 11 years though. I have some practice.
So that made you crazy.
Exactly.
Now, draw circles.
Alright, I'm actually going to take these notes.
Yeah. Okay. Geometric series is the easiest one. Like I said, you're going to really like today, and it's going to seem easy. So that's good.
It's gonna seem easy.
No, and it'll be easy. Today's not going to be hard at all.
It's infinite.
All right. Geometric series, like I said yesterday, what you probably learned about last year were 2 of them. One was an arithmetic one was geometric. We're not even going to do arithmetic because they're like just silly. A geometric series is just a series of numbers where to get from one to the next, we multiply by the same thing. So we are on series now. Okay, sequence is kind of already done. We don't really talk about sequences anymore. They just helped us to lead us into a series. Everything now is really going to be series, adding up. So just to kind of recap.
It's
The plural of series is series.
I guess.
I hate that.
Sorry.
What?
Sounds so
The plural of series is series. So what do we know about a series? If the limit, as n approaches infinity, of a series equals 2, what does that mean about the series? If the limit of a series equals 2, what does that mean about the series?
Multiply by 2.
Uh,
Divergent.
It diverges. Okay, if the limit of a series equals a number that's not 0, that series is going to diverge. If the limit of a series equals 0, what does that mean? It converges. Does it converge to 0?
No.
No. Okay, it converges to something. You can go look at the sequence of partial sums, and that'll give you an idea of what it converges to. So this is a series. Okay, 6, 12, 24, 48. And there's 2 things you need to know about it. I need to know what the first term is. We call that A. First term in this series is 6. And then I need to know what R is, and R is what I call the multiplier. And there's going to be a consistent multiplier that goes all the way through the series. In this case, it's 2. Okay. So if I were to kind of break down this series, I could write this as 6 plus 6 times 2 plus 6 times 2 squared plus 6 times 2 to the third plus blah, 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 blah. Okay, this would be like a fancy way to write it. Here's my 6. I'm timesing it by a 2. I'm timesing that by another 2. I'm timesing it by another 2. So like that's a fancy way to write my series. Does that make sense? That I can take 6, 12, 24, 48 and rewrite it like this. Multiplying each subsequent term by 2. And the only reason I'm doing this is because sometimes you'll see a geometric series written this way. That it's the first term plus the first term times the multiplier plus the first term times the multiplier times the multiplier. So this is how I'm getting like all of my terms. Don't get really wrapped up in notation, but you will sometimes see a geometric series written like that to represent its nth term, its last term. But all you really need to know is that a equals the first term, r equals the multiplier, and there's a rule. And there's a really easy rule to know. If r, or actually the absolute value of r, if your multiplier is less than 1, then the series converges. Kind of makes sense. If your multiplier is less than 1, then it's a little fraction, right? And if I multiply a number by a fraction, what do I do to the number? I make it smaller. So if I keep multiplying it by a fraction, I keep making it smaller and smaller and smaller and smaller. So I keep getting that limit to be 0. So if my multiplier is less than 1, then my series is going to converge. And if my multiplier is greater than or equal to 1, then the series is going to diverge. So this series that I have up, does it converge or diverge? Diverge. Even without knowing that, it should be pretty easy to see that the limit of this series, if I looked at the limit of this, it's not going to 0. The limit's going to infinity. It's getting humongous. So this series is going to diverge. It's way too big. I could never quantify what that all adds up to.
If you just multiply by 1, then wouldn't it just converge to whatever a is?
But then the limit of that thing would still be not 0. You know, like if it's like 5 plus 5 plus 5 plus 5, the limit of this is still going to go to infinity. And even the partial sums, like 5, 10, 15, 20, like first sum, second sum, third, fourth, this is also going to infinity.
Right.
So it's still blown up. But here's an example of where it won't blow up. So let's do this one. Okay, let's say I have this series. I'm going to know it's geometric because it has this form that looks just like this like general form I wrote. But when I first started doing this, I didn't know if something was geometric or not until I literally wrote out a couple terms of it. So when I first started, I wasn't real good at recognizing like, oh yeah, that's geometric. Because you're going to eventually have a whole bunch of series to look at and you're going to be like, is this geometric or not? So what I would do when I first see a series is give myself the first few terms and just look at it. So if n equals 0, what's my first term? 100, right? If n equals 0, 0.1 to the 0 is 1 times 100. So my first term is 100. My second term, if n is 1, I have 0.1 times 100. So what's my second term? What's 0.1 times 100? Oh my goodness.
What's this?
10.
10.
Point. One.
If n is 2, I have 0.1 squared times 100. Not so easy to do, but you are going to get 1. And if we keep going, now I'm going to get 0.1 I'm gonna get
Yes,
0.1, oh no, 0.01, right? Obviously, we get the pattern now.
Not really.
Can you please keep going?
Yeah, I know.
No.
No.
So what I need to figure out is, what do I have a consistent multiplier? What's my first term? What's my multiplier? So first term is 100, what's the multiplier? 0.1. Okay, well 1/10. Is the r less than 1? Yes. So I'll just write it all out. Because r is less than 1, the series is going to converge. Okay. So, I'm not finished. Two things. First of all, the limit of the series is going down to 0. Okay, the limit of this series is going to be 0. How do I want to describe it? Think about if we looked at this yesterday and we didn't know what we know about r and what has to be less than 1. If I think about this, the limit as n approaches infinity of 100, basically over 10 to the n. I'm sorry. Yeah, right? 0.1 is 1/10. Yeah, 10 to the n on the bottom. What does that go to? If n is infinity, what does this go to? What happens to the bottom when n is infinity? Huge, so the limit is 0. So I could have used yesterday's information to know that the limit of this series, as n goes to infinity, is 0, so I know that this series is going to converge. But it's going to be a lot easier to look at this geometrically. So we know it converges. Well, what does it converge to? What does it converge to? Well, to know what something converges to, just like yesterday, we look at this sequence of partial sums. So my first sum is just the first term. My second sum is the first 2 added. My third sum is the first 3 added. My fourth sum is the first 4 added. My fifth sum, oh my god, look at it, it's crazy.
Keep going.
So, we are obviously coming to the sequence of partial sums is coming to 111.11 repeating. Okay, so what does it converge to? It converges to 111.111111. Now,
Circles.
Circles.
no. So far, I hope that you made a connection between yesterday saying that if the limit of a series goes to 0, then the series converges. Well, here's a special case of a series. It's called geometric, and as long as we have a consistent multiplier, it's a geometric series, and we can look at it that way. If that multiplier is less than 1, the series will converge. If the multiplier is bigger than or equal to 1, it will diverge. There's also a formula. So this is probably something that Gersbeck had you guys memorize. We did not.
Probably.
Oh, it's not too bad.
No. The sum of a geometric series only works if it's geometric
Zach, what's your sample fact?
equals a over 1 minus r.
Take the lid off. I remember this.
Okay, so there is an actual formula for this. You're going to use this. So if I was doing this problem, I could have totally skipped the sequence of partial sums idea. Okay, I don't have to look at the sequence of partial sums. If it's geometric, I can just use the formula that it's going to be a over 1 minus r, which is going to be equal 111.11 repeating. Okay, easy?
Now circles.
No, let's look at like one more.
I can go really perfect circles. Camels. We have to solve the problem of camels.
Camels! Wait, I don't understand how you drew lines through one object.
The end of page, she
I didn't
used
know
the end of page.
Yeah, she made a triangle.
Alright, let's say you have this. It's not in like a normal geometric series form per se. Shh. If you don't know if it's geometric or not, plug in a couple of the n's and look at it. So if n is 1, I've got 1/3. If n is 2, I've got 1/9. If n is 3, I've got 1/27. Blah, blah, blah. So what's a?
One.
1/3.
It's 1/3. So-
Isn't the multiplier one?
No.
Wait a second.
The,
A is gonna be the first term, so it's 1/3. The multiplier is what do I get to get from 1/3 to 1/9? It's also a third.
Whoa. And then it always starts with whatever's under the.
Yes,
E
good,
thing.
yep, good point. Okay, it always starts with what's under here. So if it was n equals 0 to infinity, it would be different. My first term would be different, but it's not, it's 1. So double check, is r less than 1? Yes, it is. So the sum of them is going to be a over 1 minus r. Figure out what that is. So 1/3 over 2/3 is 1/2.
Okay. Yes.
So that seems like weird. But if I take a third and I add on the 9th and then a 27th and whatever, 84, 181st and blah, 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 it's going to converge to a half. That's crazy,
Kinda.
right?
Steve, put some of the circle things in one spot.
That's it. There's 4 homework problems though.
Oh my god.
Circles?
It's in the circle.
No.
Draw camels all
The circle has to be.
For extra credit, you draw camels in the circle.
Too bad, I'm writing to home right
I don't know why I didn't strike the odds, but whatever. It's so nice with those guys not here, isn't it? Let's talk about the things we hate most about them. Camera's not on.
No.
Monica's
So yeah, you go first.
Yours is so ugly and smelly.
Oh crap. I don't like Mac. He hates
Wait,
every
Corey,
day.
aren't you in DECA?
Yeah.
Sit down.
Can't
I
do
got
this
nothing.
perfect.
Thank you. I like that.
It's on.
We like it.
I hate you, I'm glad you guys are gone.
I bet they're
Not Monica,
I like
Monica,
they're
you're
saying
right.
screw you